BepiColombo, Europe's first mission to Mercury, is currently being put through its paces at ESA's European Space Research and Technology Centre in the Netherlands. In April, the mechanical and vibration tests will be underway. These tests are crucial so that BepiColombo can withstand the launch and the 7-year journey ahead. There's even more testing than usual, however, because this joint European and Japanese mission consists of not one, but 2 spacecraft.
One spacecraft is provided by ESA, which is MPO, we call it MPO, Mercury Planetary Orbiter. And this spacecraft has a focus more on the planet. We want to observe the planet, do remote sensing, characterize the surface, count the craters, wanting to know about the composition of the surface, the interior of that planet. And in addition, we have a second spacecraft, and this spacecraft is called the Mercury Magnetospheric Orbiter, more focused on the environment, and this spacecraft is provided by the Japanese Space Agency.
BepiColombo consists of several components in a so-called spacecraft stack. Apart from the 2 orbiters, there's also the Mercury Transfer Module, which contains the solar electric propulsion engine to get them there, and a sunshield for the Magnetospheric Orbiter to stop the spinning Japanese spacecraft from overheating. Mercury is the closest planet to the Sun in our solar system. Yet despite temperatures reaching around 450 degrees Celsius, the NASA Messenger mission found evidence for ice at the planet's north pole. Unlike Earth, Mercury barely tilts on its axis, and so some areas are in permanent shade. BepiColombo aims to follow up these findings to confirm how such a hot planet contains ice, and also what type of ice it will be. The Messenger mission found other surprises at the smallest planet in our solar system. It discovered more chemical elements and compounds with small boiling points, known as volatiles, than expected at the surface. Certain processes within the planet's environment are also much faster than they are on Earth. The NASA mission ended in 2015 after spending 4 years orbiting Mercury. It focused predominantly on the North Pole, whereas BepiColombo and its instruments can cover the whole planet, as well as exploring its gravity field, the surface composition, internal structure, and external magnetic field.
One of the special things about Mercury is that it's the only planet besides Earth who has a magnetic dipole field. And so we would like to understand the dipole around Mercury, or how the magnetic field around Mercury is interacting with the Sun. And that's very important for us, because then we can learn for Earth how the Earth's magnetic field is interacting with the Sun. And we have a lot of satellites around Earth which are affected by the solar wind and the interaction. So if we can get some clues about processes on Mercury, we want to learn for Earth.
In a few weeks, solar panels will arrive at ESA's testing facility and will be integrated onto the spacecraft. After correcting an electrical problem in the Mercury Transfer Module power processing unit, BepiColombo's slightly delayed launch is now October 2018. It will arrive at Mercury December 2025. Then, this ESA-led mission can examine the least explored terrestrial planet in our solar system, uncover how Mercury was formed, and help us better understand how the Earth itself formed.